So this video is going to give us a brief rundown of how to solve using substitution in a system of equations. We talked about graphing last video and how it's a complete pain in the butt and doesn't always work. So substitution is a nice option for us. So I have the steps written down here. First thing you're going to do is isolate a variable in one of the equations, which is basically something we did a lot of in the last section. So I'm going to start with that here. I have an example here. I'm going to run through each of the steps together. So the first thing we're going to do is isolate our variable, right? So we have 4 different variables to choose from. One of these variables is enormously easier to work with than the other 3, right? And that is going to be this y. This y is going to be the easiest thing to solve for by itself because it doesn't have a coefficient. We don't have to do any division. All we have to do is one step and we've got this variable isolated. So I'm going to go ahead and rewrite our first equation along with that step. So we're going to go ahead, 2x plus y is equal to 6. We want to isolate this y term, right? That's the whole goal. So if we want to get that y alone, what we need to do is to subtract 2x so that that cancels. And then our y variable term is actually isolated as well as the variable itself. And it doesn't matter what order we put that in. On the right side, we could do negative 2x plus 6 or 6 minus 2x. It really doesn't matter. So step 1 is now done. We have isolated for a variable. All right, step 2 tells us that we should substitute for that variable in the other equation. So now we're going to bring in, for step 2, the other equation, 3x plus 4y is equal to 4. And if we have that y is equal to 6 minus 2x, we can go ahead and replace our y in the second equation with that. That's the substitution part of this entire solving using substitution. This is it. So when we write this down, 3x plus 4, you'll see here in the steps, I made sure to say using parentheses. So when you sub in, make sure you use parentheses because this is 4 times the entire y. So this whole thing needs parentheses around it, and this is all equal to 4. Now we're ready to do step 3. We have an equation with only x's. We have basically, this is the goal. Yay, this looks like our last test, right? We can solve this. We know the steps to solve for our remaining variable, to do step 3 for this. So step 3, first thing we'd probably do is distribute to clear the parentheses. Then we would combine up our like terms, right? We can see that we have 2 like terms there. So we have a negative 5x plus 24 is equal to 4. And then use our addition principle and our multiplication principle to finally solve for x. So we get x is equal to 4. Now, like I said in class, we want to make sure that we don't get ahead of ourselves and just box this up and call it an answer. Because our answer is an ordered pair, we need a point where these 2 lines intersected. So we need to figure out what y is. The nice thing about the substitution method is that when we go to do step 4, the easiest thing to do is to use the equation in step 1 to do this. So I'm going to bring back this equation that we had, the thing we subbed in, y is equal to 6 minus 2x. And this should be the easiest thing to use because we need y and we have x, and that's exactly how this equation is set up. So if we want to plug in y is equal to 6 minus 2, and then we can plug in that x we found over here of 4. And if we finish that up, we get 6 minus 8, which is a negative 2. So we are now almost to our final step. We have been told x is equal to 4, or we found that x is equal to 4 and y is equal to negative 2. Our last step would be to check our work. So we can plug into both of our equations. 2 times 4 plus our y is equal to 6. That was the original equation. this one, 2x plus y is equal to 6, which is true. And then we have to also check in our second equation, which was this one. So 3 times 4 plus 4 times a negative 2 is equal to 4. 12 minus 8 is equal to 4, which is also true. So this thing is definitely our solution. The only thing we have to do now is to put it in a nice, beautiful ordered pair and box it up. So that is step 5. Check your work and then make sure you put this into an ordered pair. So that's solving using substitution. I'm going to give you guys one more example to try out and see what you think. See if you make any mistakes or if you have got it down. I'm trying to figure out which one I'm going to give you. So I'm filibustering at the moment. Let's do this example. Being really slow. Let's do this. M minus 2n is equal to 16. And 4m plus n is equal to 1. All right, so give this a shot on your own. Feel free to pause the video and then come back. I'm going to get started right now. So first thing you need to do is to decide which variable you're going to solve for. There were 2 good options here. Either one would have been great, either solving for this m or this n. They both would not have you do any division. They will not create fractions, so they are the ideal ones. I am going to choose to solve for this m because I realize that if I use this equation, that my first step is going to be to add 2n to both sides, and everything's going to be nice and beautiful and positive, and I don't have to worry about distributing negative signs, which would happen if I went with the other one. So we have m is equal to 2n plus 16. And again, you can write these in whatever order you want. I just chose the sort of more slope-intercept looking version. So again, either one, a lot of choosing which one is going to come down to practice, and you're going to realize I make more errors when negative signs are around, so I try to get rid of them, as you guys have seen in class. So we have our m, solve for our m in this one equation. The second step is to actually do our substitution, right? Sub this thing in. Step 2. We're going to bring the second equation over, the one we didn't use in the original, and we're going to plug in this whole thing is m, so we're going to plug that in where m is, right? So we're going to do 4. We're going to use our parentheses so we don't make any mistakes. We distribute, and plus n is equal to 1. That is a common mistake I see students do, that they forget the back half of this, the plus n. So just be careful when you're doing this. Another mistake I see, just to talk about it, is when students go to grab that second equation, sometimes they will not grab the second equation. What's going to happen if you do this, if you plug this back in here, is you're going to get this. 2n plus 16 minus 2n is equal to 16. Oh, the 2n's canceled. 16. Oh, crap. All my variables canceled. Variables cancel when you have either parallel lines or the same line. In this case, since 16 is equal to 16, it's telling you it's the same line. And it's the same line because you plugged in to the same line. That's why it's so important that you choose a different equation, the other equation to plug into. So with those cautions out of the way, we can go ahead and continue moving on to step 3, right? Because now we have an equation that just has n's in it and we can solve. Right, so we have distribute. We can combine our like terms. So we have 9n plus 64 is equal to 1. We can isolate our variable term. I'm just going to go up to the top over here. 9n is equal to negative 63. And then we can isolate our variable. So we get n is equal to negative 7. So we've got one variable. Step 4 is to go back and get the other variable. And again, smartest thing to do is to use the equation we already have for that other variable and plug into that. So m is equal to 2 and then we go plug in our n that we got, -7. So in this case, m is equal to -14 plus 16, which is 2. Now, this is another one that students get confused about when we go to do step 5. I'm not going to check this one because the video is already getting real long for 2 examples. But you do want to still write your answer as an ordered pair. If your variables are not x and y, you just write that ordered pair in alphabetical order. So m comes before n in the alphabet, so your ordered pair here will be 2, -7. So that's your final answer. So hopefully that was helpful, reminded you how substitution works. You always have those steps available to you. I'll publish this document as well in our Blackboard folder so that you have the steps and the corresponding work right next to them available.